All right. As you can see, the power's off. You want to come over here and check this out. My man. You get the volume on the TV too?
Yeah.
Oh, sweet. Look at that. That's 5 milliseconds. 1 volt. Wow, that is freaking weird, don't you think?
It looks like a wave. You can get all detailed about it.
Well, so look at the power supply. I mean, look, the power is off.
Look at the detail there, y'all. Nothing.
All right, man. Let me turn it on. Let's see what what happens when I turn it on. All right. Now we got 2 oscilloscopes hooked up to the exact same thing, but they read differently.
Ooh, you're putting some juice in it.
Yep, that is 32.6 volts.
Just started spinning it.
All right, now that that's spinning, I'm gonna spin this one. And there's that what you just stepped on is something that I'm gonna show people about the wave.
Okay. My bad.
Just so what's on the floor now, Ben?
No, right.
No, just put it in here.
No, I meant that was my bad on the first one.
Oh, okay.
Yeah.
But here, like we get the wave. This one's actually hooked up to this coil right here, and this is what's coming off of that coil because it's in a loop with this pulse motor. So I believe I can't tell the time.
How's it going? How's it going, Cosimo?
Hey man, how you doing? It's 10 milliseconds. So this is every 10 milliseconds. And it's reading like that because it's hooked up to the pulse motor
This is a pulse motor.
in a loop.
Do you know what pulse motors are?
Currently it's set up to be more of a toy.
How's it going, Woo?
Woohoo!
Yeah.
So this coil alone is producing enough electricity to run this pulse motor at that speed. With 32 volts in to that pulse motor. So the big one spins, then this one can spin at a speed, and then we can make the big one spin faster, and then this one will spin faster.
We are from Michigan in the United States. Where are you from? You can hear that humming.
Yeah, I can. And then behind you, we have our next gyroscope mechanism. So we got the rotor, and we got the base. I'm about to attach one of the arms, one of the coils. And we're going to see see if we can't get that rotor to spin, just the pulse motor kind of floating in midair.
Yeah.
The Great Lakes.
Yeah.
Yeah, the U.S. is in the Great Lakes, or
You got it. Other way, it's all
other way
good.
around. You
Right.
know, the Great Lakes are in the U.S. My fault.
And we can
I
just
don't want
say
to confuse anybody.
No.
Look how fast it's going now. That's amazing. Because it's just late. It's just energy from this one coil right here.
that is nice. Booyah.
Um, yeah, currently the loop is generating about 400 volts, 400 volt peaks with 200 volt average. The RMS is 2100. And the hertz are between 100 and 130 for the energy in this coil. And it's that low because it's running a pulse motor, which is definitely going to register as a load.
Right.
So I'm also, this oscilloscope is hooked up to the drive. So it's measuring the square wave that's coming off of the drive circuit. And there's one thing that I wanted to, but I can't see it.
How's it going, Splash?
Bass Flash.
We're working on looking at sine waves.
So I'm going to cut this, and I'm going to hook up my diode that's going to connect the end of this thing to the beginning of this thing.
Okay.
When I say this thing, I mean this thing.
Right on.
Alright, so we're going to take it from the back end. And we're going to bring it around to the front. Alright, and because it's a directional shot ski, I think it's probably what it's called. It's the fat diode.
Yeah.
Uh-oh.
What will the sine waves tell us about the project? We're
We're going to take that off because something obviously isn't working.
I'll let him answer when he's ready to answer that one.
This was to make the drive circuit a loop as well, or have the option of looping.
So what the question was about the sine waves, though.
Okay.
What will they tell you about the project?
Well, this one in particular told me that that there was a pulse in the loop. All right, so that's one thing that it told me.
Right.
So like if the energy would flow through when the circuit over here is closed. Okay?
Okay.
And it's closed when it's moving. It's not closed when it's open, unless it's chilling right at the reed switch and then it'll close. So I think we're going to slow it down so we can actually see the sine wave. Slow it down, my bad. Alright. Here it is. Perfect. We can see it way better now. So what that is they're here, shoot. Here, this is it. You got your square wave, and then you got your pulse, which looks like a 3-mile long tornado. It starts really fat when it comes off the square wave, and then it just cycles down into the next square wave. So, yeah, I think it's really a unique pattern. I'm not trying to compare it to anything. I'm just trying to, catalog it. So we just had to get it up past the point where it was being dragged by the coil here. This does tell me that it is not high frequency. It's only about 130 hertz, and that is not going to cut it. I'm trying to move this rotor right here. Right now I'm moving it like this, but I'm thinking I'm going to turn it upside like this. I'm going to try and hit, one of those Flux motors.
Hey, Peter.
Hey Peter, what's up?
And then Splash asked, so the ideal sine wave is a straight square wave?
Oh, ideal? I mean, the word, I kind of get it. Sine wave is going to be rounded on the top and rounded on the bottom, and that's the ideal one.
Okay.
Square wave is going to be square on both top and the bottom. That's the ideal square wave. Now when you got all these spikes happening, and then what it is multiple spikes that can happen consecutively, and as it gets towards the end, they're very small on the oscilloscope. The range isn't that great.
Hey everybody, welcome to the channel. Thank you for stopping in. Drop us a like. Let us know your thoughts on magnets, pulse motors in the comments.
So at 22 volts in, we get this out of this motor with this drive set up the way it is, running on this coil, and we get that out of that motor with its reed switch and the 3 Bifilar coils. The Bifilar coils go 30 gauge to 26 gauge. DC connection. But this, man, I've been working on this like for the past 20 minutes before we started. This is like the next step up for so there's this thing underneath here, and it's going to clip on like that. I'm going to glue it on, make sure that it stays, and that's going to be perfect.
Yeah, that looks nice.
That is going to be perfect. This is going to spin this way, this is going to spin this way. Yeah, but we're only going to run it as a motor for the first test. We're going to try our 26 gauge coils, single strand. And if those work, that's good. And then we'll try one of the bifilers with a core in it. We'll see if this thing can do some core. I don't think it will. I think it'll sink. That's what I think it'll do with cores in it.
Okay. Awesome.
We'll just test it.
Painting school, Peter.
Heck yeah, man. I love doing it. That's what I did that a lot before I even started doing this. Like, just calms me down.
I want to thank Peter Holofac 2.0 for moderating this evening.
Thank you so much. I really appreciate you doing that.
And you guys can hit him up in the comments. Do you have a timeline for this one?
Oh man, that could be like tomorrow. Depends on how like crazy involved I get with it.
He said it could be tomorrow.
I mean, if I get it done tomorrow, I'll bust out with a live stream and be like, I got it done. I can't believe it went so smoothly. But I mean, sometimes it just doesn't go the way you want it to. Like the first iteration of the arm didn't have the platform high enough.
Here, get a better angle. Put them next to each other. Hold them on like this. In here, like that. There. And then move your finger here so you can see it. There we go. Now, go ahead and describe.
All right, this was the first, shot at it. And it looked like it was going to work, but then I needed a little bit more magnetism in there, and it ended up raising it a little bit, so I ended up lifting up where the coil will go by, like you see, about a ½ inch.
Mm-hmm. That's very nice.
And it's got the extra supports here, so it won't be all flimsy. It's a little bit thicker than the other one. And we're moving from 32 gauge coils to 26 gauge coils, but they are the same length. They are 1,111 turns.
Yeah.
We're getting nice arcing going on in the reed switch over here.
Yeah, high speed needs that extra support. So you did a good job in the redesign.
Yeah, I think it'll work out just fine. That rotor, I mean, these parts, this part down here is a little bit constricted by the weight of the rotor, so it won't spin for as long as the rotor will, but I mean, once you get it pushing it, you can't really tell. But this one won't spin as long. I can put some graphite powder on there and see if it has anything to do with the bearings, because these bearings are freaking perfect. You see that, right? They're so moving so good.
Dude, it's smooth.
Can't wait to get it running with a motor. See, like the Celtic Cross rotor has got a stack of 3 magnets in it. This one only has stacks of 2, but it has 6 stacks instead of 4. Now I could try a gyroscope with the 4 magnet rotor as well, just for the hell of it. Yeah. Oh, I was meaning to ask you, Peter. All effect. This right here. Can I use this as the jewel ringer setup? just a bigger one. I know it's not a ferrite core, but it's very magnetic. At 29.8, that's picking up some speed.
You said, can you ask that one more time for the what you're holding?
You made a video today, this morning, and I used this rod to be the core for that coil or transformer.
We're eagerly awaiting communication.
You know what?
He'll need to watch it. Okay.
Have you used that? No, it's your video, Peter.
So you need to ask it one more time.
All right. So you have a jewel ringer apparatus that you made a video about this morning. You used the ferrite core that you got out of the computer or the whatever it was, the record player. You got a ferrite core out of it that was 6 inches long, I think. Can I use this core to do the same thing? Oh, okay. Yeah, that was a nice one. This is 12 inches.
Thick.
And a half-inch thick. But it's not ferrite. It's stronger magnetically than ferrite. It's too much. That's kind of what I was asking.
Thanks.
Perfect. Okay, that's good. I don't really want to.
Hey everybody, welcome to the channel. Thanks for dropping in.
Hey, what's up, everyone?
Drop us a like, subscribe, leave us a comment. Let us know if you love pulse motors, magnets.
So this bobbin, which is just a C clamp that I, broke the clamp out of. There we go. I'm gonna wrap this with probably thicker wire. I might do a Bifilar style coil, but with thick wire.
Yeah.
So I think this is going to be an awesome C-shaped electromagnet.
Yeah.
It's going to be awesome, and I need 12 of these bad boys. So I was thinking,
Yeah, and it's magnetic. I think they're iron.
yeah, cast iron. Okay, 14 gauge and like a 16 gauge. Because the idea here is to generate a lot of AC current
Right.
with nothing. You're generating it from nothing. That's what this is really about.
That's right. Yep.
Oh no, man! The one that I'm making. It's going to be about 8 inches big. I'm not making a roadster. I'm not making a roadster that travels into the heavens in my bedroom. It's not.
Yeah.
Unless that little one can make it happen.
A 45-footer.
45 foot? Yeah. No. No, I think that's longer than the width of my house. I don't think so.
Hey everybody, welcome to the channel.
But I could like do a smaller one.
Drop us a comment and let us know where you're from.
So I've been watching how to get, the freaking aluminum rotor to spin with electromagnetism, and it's all leaning towards the flux motor and having fat wire involved.
Oh yeah. Yes, sir.
That would mean that you were with us in the other room.
Yeah.
Absolutely.
People love pulse motors. We appreciate that very much.
Yeah, I like the other room better. All right, so we're gonna make some fat coils, and we're gonna roll them all.
Hey Nasser, welcome to the channel. Thank
Hey,
you for
what's up?
joining.
Hey, thank you very much. You can get on the Discord and we can talk.
Yeah, custom collaboration on it.
You can even send us your own design if you want to print it. Parameters are that it be 8 by 8 by 8, or within those borders. But yeah, the gyroscopic things, I was actually thinking about making those. I made
Here, I'll get it
one
up.
for sure. And I was just thinking, since the OTC X1 had a big accumulator in the center, right? I was hoping that I could make the accumulator out of, aluminum wire. Have it be a big ass coil instead of, a solid piece of aluminum.
Okay.
Because that's crazy expensive. It's not even within the realm of possibility at the moment. But this is.
Yeah.
I can do this right now. I can do this tonight.
That I don't know.
Well, I read up on the neutrons a little bit. I watched a video on just basically what you have suggested for me. And I learned a lot from that. Like a lot. I learned a tremendous amount from that. Oh, on the whole site, I'd say 1 for sure. I haven't even scratched the surface.
I think that's pretty cool, bro. Yeah.
But I'm getting an Utron printed in aluminum, solid aluminum. Hopefully it won't be too hollow in the middle.
It's kind of you used to play video games the same way because you play the entire map and you learn how to get to the next step one piece at a time. Yeah. So you're going across the board on this, and you're doing a lot of things.
See, the ones the gyroscopes that I'm making use magnets, and they're easy in my mind to make. But the ones that thing that he's talking about uses no magnets except the electromagnets, which are powered. The way that it's powered isn't. It's powered by itself. It's powered by the interaction between. And the way the neutrons are supposed to spin, I don't. As soon as you get them spinning, man, you'll have enough energy to do whatever you want with. But getting them spinning is, what's boggling my freaking mind. But I'm going to build this, and we're going to see. If I can get this is a test. If I get the aluminum rotor to spin, then everything else is downhill from there.
Yeah, that's the hardest piece, you're saying?
Yeah, that's it.
In your current understanding. Because I think you'll be able to get it for shout. Hey everybody, welcome to the channel. Thanks for dropping in.
Because, in scale, that's what the UFO is a giant pulse motor. that runs on itself.
Yeah.
That's what it is. There's so much gyroscopic stuff going on inside this thing that if it actually works, I'll be so thrilled. I'll create my own little time machine.
The time machine.
In my hands. I don't know if I'll be able to walk through it. Dive into the little 8-inch space, but we'll see what happens.
Thanks for dropping in this evening, folks. Drop us a like, subscribe, leave us a comment, let us know where you're from, what kind of DIY projects you're working on at home.
So we got drive, drive, drive. Then we got obscure coil, trigger coil, and one spot left.
One spot. And could that one spot add to what you have here? And can it also take away from what
You
you
can
have?
definitely take away from. When you get to this point, adding this is it right here. You add the last freaking coil, and then it all just kind of falls apart.
Yeah, because there's
you gotta start over.
a lot of connections that you got to remember. Yeah.
But these little connectors have been a blessing.
For sure.
That eliminates so much extra length that I have in my circuit. These things are literally like 6 feet long or something. 3 feet, 6 feet.
Have you ever hooked up a variac to a microwave transformer?
No.
No, that sounds fun. Oh, that's where you got them. Okay. So yeah, everybody,
Okay.
Peter Holofact 2.0 has a masterful skill of reclaiming from old appliances. It's amazing. Check out his channel.
Heck yeah. All right, here we go. The bounce.
One more time. I love that.
The souped up maglev. I'm gonna do that arm on there real quick.
And they're the same principle with that one, but it bounces a little less.
All right, so this is gonna go. Oh man, don't want to get this wrong. Probably gonna need to. This is what. No. That's good.
Yep, we'll call it the little.
The first one is easy. The next 5 I'm gonna have to draw out with a Sharpie. hate glue.
The glue spider web.
All right, so that's gonna dry or cure whatever it needs to do. And then I can put this on here now. We'll see exactly what the fit is, if I got it right or if I need to make it a little bit more pronounced.
It does look like a clock with one hand.
So that's pretty good. I mean, I could probably remove some of the double magnets I have in here, and that would make it a little better. Alright, so
Hey everybody, welcome to the channel. Feel free to drop in on the conversation in the chat. Leave us a comment, let us know where you're from. Drop us a like if you love magnets and pulse motors.
So that's good, right? See, look at how smooth it is right there. I mean, it's way better, but I don't think it'll play a big part once you get it moving.
Yes, and definitely science, because we're able to replicate things together. So our community rocks. And there are people with backgrounds and without backgrounds participating, and it all works, guys. It's very fun.
Heck yeah. Alright, so we got our coil. Man, you see how quickly and smoothly this is going?
That's nice.
Now, let's see here. Do we need a bigger platform?
Did you already design that?
What, the cap?
A bigger platform kind of thing?
Yeah, no, I haven't done that yet.
Okay.
This is the first time I'm actually getting this far, but it'll be like a wider.
Thing for it to rest on?
Yeah, but that's good. It's a quarter inch. I mean, it should just work real quick. I can always change it. And it take a little bit more for it to melt. We'll see if this is all going to be too heavy in a second.
Oh, dude. Just a little blurry. There we go. It looks straight to me.
Yeah? Pretty good, right?
Yeah.
Little drip there.
Little drips. The glue manufacturing facility. All right, so, yeah, well, reclamation. Hey, everybody, welcome to the channel.
Alright, so let's get some power on this thing.
What's up there?
Want to just hook it up to, well, we need a reed switch and whatnot.
Oh, yeah. You got this. I'm excited for that. Hey, Robert, welcome to the channel. Thank you for that. Poland in the house. We appreciate your time, and you can practice your English with us.
Kilowatts.
Yeah.
Hey. How's it going? Awesome. Alright, so
We're going to try and hook this in.
Yeah, I'm just debating on whether I should move this power supply over there and use it. I think that's what I'm gonna do.
Okay. Huh. That's a good question, Peter. I might have to think about that one. But I do like it. I really, really like it. And I like how you spell it too.
Yeah.
So I'm actually thinking yes, I would vote for that. But I really like Peter Hall effect too. Boy, no. So I do like that.
Alright, so we're gonna plug this in over here.
Yeah.
Oh yeah, you saw that.
Mm-hmm.
Snap, crackle, pop. Alright, so we'll get 2 clips.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe. Let us know your thoughts on the science of electromagnetism, working with pulse motors. Or if you're doing any kind of do-it-yourself at home.
Get a fresh one. Take this. I like that.
I like that. It enables you to fully express yourself also. I agree with that.
Oh, okay. So connect this here like so. And we'll put this in here like this. Oh man. I did that backwards. But I think we're gonna be alright.
Boom, the instant pulse motor. Excuse me.
Alright, and then we just gotta click the negative. And then we gotta get the reed switch in place.
Hello, Caleb.
Hi, son. Alright. So we're pulling
Here we go.
it does want to go the opposite direction when it pulls up to one.
Okay.
There we got some arcing.
You want me to move it?
Well, I'm gonna have to put it on the coil.
Okay.
It's being kind of
What's up, Chris? What are we doing here? So we are working with setting up a gyroscope pulse motor. And this is the beginnings of it, where we're going to have the rotor turning one way, and the case, the surrounding, turning the other. And the coils will be held in the surrounding. And it's all powered, plugged in. And this is definitely for fun and science, data collecting. And we print out all the parts, so it's pretty cool. Yep. Have you ever worked with pulse motors or electric motors, Chris? So how do the fields interact when they're going the opposite directions? How would you describe that?
I would say that they push on each other, that they redirect each other's energy very well. And they do it pretty much on their own. That is working, but it's not great.
And then Nova Stang gal says, I was going to do something like that with the ceiling fan.
Nice.
Awesome.
Heck yeah, man, that's powerful.
That would be actually really cool. With like a gyro ceiling fan. Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe, let us know how you feel about magnets.
Magnets.
I mean that is the I love magnets too. Just by watching him over my lifetime.
So we're gonna try
Right on, Nova Stang.
one more time. We're gonna try.
I'm gonna go get the ones in there.
All right.
All right, now where would you put it on this coil? Like right there, right?
Yep. And then I think it shouldn't affect the equilibrium, but then you got to balance them out on the rest of them.
Well, there's only gonna be one if I do it right.
Oh, perfect. Okay.
Yeah, I mean, you can make it because if you make each one have its own, you got to make each copper ring down here for each one of them because the collector pins can't cross. You can have them all on the same negative, but they all got to have a different positive.
What application for a gyro? Oh, understood, sir. I got it.
Sorry, I'm confused. What's that?
Nova Stang,
Yes.
I believe saying TGE gal is Mr. By the way.
Yeah, mine. I got so many magnet balls.
All right.
Nice. Those are cool.
Yeah, you can do the gyroscope to produce electricity for your home. Straight up.
Yeah, that's. We need to figure out what's going on with this real quick. How we're gonna make it. Gotta find the right position, or we can just put it down.
Oh, we got a cat.
Hey,
Hey.
don't blow my ear. One.
But this will not spin the other way until I make a commutator contact plate for it and a brush. So it's not going to do that right now, probably not tonight, but we'll see. I got lots of copper here to make another plate, so
We are in the Detroit area. What is the power factor? There we go.
It's too high and the reed switch is not working right now.
Yeah, 0.700 milliamps. Wow.
I think it's broken.
And yeah, we are in the lab right now. This is the lab. Papa Bale's laboratory. I love that. Complete with the coil winding machine.
Alright, see, I don't know why all these other ones are working just fine. This one, no problem.
Iowa in the house.
Hey, what's up? Iowa. Is there... I don't know. Because there's like every state I think is cool. Is there any state out there that people think might not be cool?
Oh man. A not cool state.
I don't know. I'm not a hater. I think they're all nice. And I mean, the beauty of each state is pretty awesome. I mean, there's only like 20 states that I haven't seen, at least driven through.
We have one vote for Missouri on the negative list.
Oh. Well, yeah, that's one of the ones that I only driven through.
I've driven through a few times. I think I've stayed in Joplin a bunch of times on my way to New Mexico.
We got some traction. It's definitely not in the right position.
Oh yeah, you can see it wanting to move, but it's tethered down because we don't have a commutator.
No, that's blown.
Oh, the switch blew.
Yeah, it was working. But see, it's in the totally wrong spot. I don't know what the difference is between that one and this one.
I'm excited for this one.
Me too.
I like that design.
We're gonna find it, and then it's gonna be gold from there.
For sure. Hey everybody, welcome to the channel. Thanks for dropping in.
The reed switches have always been like really touchy.
Drop us a like, subscribe, let us know if you guys have worked with pulse motors in the past, if you're doing any science projects at home, if you've got a lab somewhere on your property that looks like it's being used. Heck yeah, it will. Let us know if you have any comments, questions in the comments.
I was going.
Let us know where you're from. And the amps is what you're looking at?
No, I'm looking for the arcing. And the
Oh,
rate
got
switch.
it. The visual evidence. See if I can zoom in on it.
It's not happening right now.
Okay.
But yeah, you can. And just you turn it up.
Germany in the house.
Hey, what's up?
Peter.
No, these reed switches are really touchy.
Okay. Are they the here? Oh yeah. That was
I need a gold-plated one.
those ones on the top there.
I don't know if this is blown. It's just not. It's sticking.
It was doing that earlier too.
Oh, this is hot. This coil's hot.
We got a hot coil.
So I'm thinking that maybe a bifilar coil will be better.
Okay. Hey everybody, welcome to the
Or
channel.
at least it's got to work. I can't just chill open like that. That coil's hot. Or closed, I mean.
Thanks for dropping in. If you want to support the channel, we do have memberships available,
All right, gold-plated.
and we have options to get in on some collaborations for some 3D prints that we can send to you.
And you can check the arcing in this one. It's freaking nice. And can somebody like try to fill me in on what's different over there and over here? I'm struggling with that, but I think it's just position. Not bad.
You're good.
So maybe we go through the coil first instead of through the reed switch first. Don't know if that would make a difference, but we got some arcing in there.
Yep, I got it.
Alright, sweet. So we can put it there.
Nice.
Sweet. Alright. Do we have any glue left? No. I'll bet that.
Glue stick.
Oh. Thank you, sir.
Mm-hmm.
It is hot. Yeah, so definitely a bifilar coil. It's going to be the final answer to this. Because yeah, this coil's already getting hot.
Bandini style.
Heck yeah. It'll keep it cool.
Yep, got it.
Either going the wrong way or. There we go. Oh.
There. Yep. That's bright. So what are we looking at here, Papa Bale?
We are looking at the start of another gyroscope. I'm just running it as a motor right now to see if these are the coils that I want to use and whatever.
Nice. If anybody has any questions, drop them in the comments. Let us know where you're from. Drop us a like.
Oh wow.
Excuse me.
There it goes. Okay. That's way too high.
Okay, so the glue and the coil. So the stand needs to be a little more.
No, I need to. We're not going to use this coil. That's just real simple.
Got it.
And maybe we'll put the cap on here. If that's what you were referring to.
Yeah, a little more balance.
A little bit more wideness, yeah. We'll print off something that'll fit there. Just the right size too. Okay, so the bottom line is one of those coils that's on the floor banger right there is probably going to be one of the ones that I test this out with for real. But I don't know about dismantling that just this moment.
We'll make it happen and we'll do a dual live stream collaboration.
Heck yeah, man. There's a lot of stuff you can show us, and it'd be so fun.
That's right.
Right here. Got a bobbin. I can even make one of these bad boys right now. But I'll probably end up just swapping them. Whoa. Yeah, that sucks. When the reed switch gets stuck and it's really high, it'll push through the max amount of amps that the wire can handle. Yeah.
Yeah.
Yeah, man, me too. I gotta talk to my Patreon too.
Yeah.
So yeah, that's gonna be good. Or I could make a different size for this. That's just the size of the thing right here. Make it a little bit wider than this, and like shrink it by half. We could do that, and it would work just the same. Fit probably the same amount. Yeah, heck yeah, man. When the reed switch filament gets stuck together, then the amps go. As many amps as that wire can handle will start flowing through the circuit. And then again, even more sometimes. And immediately you get instant heat and negative effects. And when the amps are flowing like that, you're probably going to burn something. Something's going to blow up. Wow. Wow, that's hot. It is hot. Like the whole thing, the core of that thing is hot, and it's an air core.
Wow. Yeah, that's hot.
All right, so man, I kind of do want to test it though.
All right.
Short of rolling one up right now. Because I think even with a core, these will be a winner.
Hey everybody, welcome to the channel.
Hey, hey.
Thanks for dropping in. This is Papa Bale. We're working with pulse motors, magnets, doing scientific experiments, and learning. Drop us a comment if you have a passion for magnets.
Heck yeah. All right. So I'm going to take this one. See that, I'm hoping that it won't sink once it starts going. If not, if it does, then I'll have to take it out, of course, core. It's good though. If it gets going a certain speed, it won't sink, which is good. With love and respect. All right. trying to figure out which one of these. I think it's this one. For sure. Oh yeah, I need a fresh reed thingamabobby.
Fresh little reed glass.
Gold plated ones would work the best. You got the plastic ones, but I haven't got one of them to work right. Alright, here we go. See, now I'm thinking that if we have it go into the coil first, but I don't know, because I like to think that the coil is the heart of the pulse motor.
Mm-hmm.
I don't want to put too much stress on that glass, so I think I'm going to glue it first, which is probably not good. I don't know which way is the best way to do this, because if I get the position wrong, then I gotta move it, right?
That's right. Hey everybody, welcome to the channel. Drop us a like, subscribe, let us know where you're from in the comments. If you got any projects like this going on at home. Appreciate that, Peter.
Just above should be a good place, you know?
We kind of do. What up, Crip Skills? We kind of got one right here. But I'm not, just for commutator's sake, to get it to move untethered. Do you know what a brushless escape is?
Pulse motor.
Okay. There we go. Electronic speed control. Got it.
Oh, I see.
So yeah, we are gaining skill here, and we are looking to get into that. But we are self-learning, self-taught, and definitely taking feedback from the community, so we appreciate that. Does look smooth.
this one's working.
The switch.
Yeah.
Is it a link for ESC script?
I'm gonna try just flipping this thing over and see if that works. But this is.
Hey everybody, welcome to the channel.
I'm gonna try one of the plastic ones and then, yeah, I don't know.
We're working with hooking a reed switch into this setup.
I got a Hall effect sensor that I could try, but I need a transistor to make that work. Oh, did it fall?
It did.
Alright. It's not hot, so we need to get the. Oh, yeah, okay, we're gonna not do this one.
Okay.
Alright. So, well, I mean, I gave it a shot, and apparently my 26 gauge idea doesn't work very well.
Yet.
No, it can't work. So I'm going to do 32 gauge, and I'm probably going to do double the length or triple the length of the ones that are down in here.
Okay.
They get too hot. It works over here. Maybe I'm wrong. Maybe I'm wrong. It works here, like flawlessly.
I think it's great.
Heck yeah. It looks good.
You got to work with what you got,
Yes, I do.
and you try many different ways. So what else could you ask for? Hey everybody, welcome to the channel.
All right, we're good. The loop is looping.
Nice, look at this spin and the pickup.
All right, flawless over here.
Yeah, drop a like if you like that.
Woo!
And it's still kicking. Oh, yes, yes.
Woo! So when the shaft starts shaking, the coils that are glued in there are a little too close for
Yes.
that to happen.
Starts hitting the plastic a little bit. Yeah. Dude, that was awesome.
Heck yeah.
Welcome to the channel, everybody. This is Papa Bale.
Oh, I think it's going like 500 maybe right now, maybe less. 450. Let's see. 368.
He was saying at the when you cut it
Oh.
off. Might have been going a little quicker than that when you cut it off.
$750. $850. $905. Heck yeah.
Okay. Yeah.
I'm hoping that my next design will have a top support with it. I don't design these shafts. I mean, they just come in the mail. All right. I love it. So we're just gonna leave it with enough juice, like 25.
I can barely see that. I'll get over there.
25 volts in, and that'll keep this pulse motor going at a nice clip.
Hey, John Paul.
Hey, what's up, everybody?
Yes, can you play records on this?
I think it's going a little bit faster than 45 hertz,
I love that question.
but yes, you could fit one on there for sure.
We'll keep that one in the minds, yeah. Thank you for dropping in this evening. Drop us a like, subscribe, let us know your thoughts on electromagnetism, pulse motors, magnets.
All right, I got a serious question about this gyroscope. The Bifilar coil was not hot when I take the core out of the Bifilar coil, or roll a 32 gauge coil that is on that bobbin instead of this little one. Which one should I do? Should I just try both of them anyway? The final go, I don't know, man. I haven't even thought about it. Right.
It's kind of a continuous learning.
It's a learning experience.
Yeah,
There's no like end right now.
And it's getting the community is involved, and the community is getting huge. I love the collaboration.
The gyro is for fun. The gyro is to prove that it works.
Yeah, and there's the one there's our pilot right here.
And that one works.
Yes.
The gyro with magnets in them is just for a gyro. There's no like, if somebody likes gyroscopes, it's for you.
Yeah, yeah. But we are learning individual things at the right time, and then we're able to just watch the evolution through some of the videos. It's pretty incredible.
Yeah, I got an idea for now.
Mm-hmm.
Well, no, actually, I don't want to do that. I was going to move that rotor over here, and I was going to move this coil over here, and then I could spin that one on this. It's not that important for me to see a spin right now.
Okay.
Eventually, I want to have everything running on its own trigger coil, because it's like the best, smoothest.
And we kind of want to be able to teach and learn at the same time.
Reed switches are good though too when they don't die on you.
Nice.
Thanks, Peter.
I like the drift cars. Appreciate that, Peter.
Nice. So you actually have an industrial one. All your stuff is kind of what you work with isn't like this. It's like stuff.
Fabricated out of metals and stuff like that.
Right. It's industrial.
That would be nice to have a metal fabricating machine.
Yeah, man. Then I could make a base out of metal
Yeah.
and have a shaft sticking right up out of it, and it wouldn't like wobble around unless it was really, really top heavy.
Yeah.
Alright. So I'm digging this 26 volts. That's moving like that at 26 volts. It's right around 350. 350 RPMs over there. And then this one, gets enough. Its arcing is nice and white.
I'll get that still. There we go.
Super light.
That's how you can tell it's working when there's any amps going through there.
No,
Or
anything.
maybe it's voltage. Yeah. I'm not sure what makes it arc, but all I know is that it's working when it's arcing because you can see it working.
Whoops. Hold on.
It's not sure. It's not so that again.
Alright. So, what are we going to do?
NOS into 2. So nitrogen. What is NOS again? Is it what is it? Nitrous.
Oh yeah.
Yeah. We're looking to see what kind. Sorry about the hand. We're practicing cameraman skills. Do you know what kind of gas is in the tube?
Oh, we just hit 1 hour and 29 minutes.
It's normally open.
Well, if you made this
so
far in the
it
video.
pulls it closed. The magnet pulls it closed.
It's fine, it's all gone now. Can't touch anything now.
No, I think we're just gonna.
But I do feel like I get random switches in here and they do both. But these are supposed to be normally open. I see, yeah. But whatever be it may, it's definitely a sign that it's working properly. But that is neat, and it's like plasma, right? It's a plasma reaction.
Nice. How's it going, Sean?
Yeah.
Welcome back.
I love how bouncy that gyroscope's gonna be.
Yeah, it's going again.
That's so
It's always going to be bouncy. On that one, you can make it to this.
Right. So either you can have a transistor switch which will actually be activated either by a Hall effect sensor or trigger coil. Or you can use a reed switch, which will pretty much do the same thing. Reed switches are finicky though, man. You gotta find the right position for them to work properly, and that's what I was struggling with over there with Gyroscope.
582.
And when I did find it, it actually was too much. The wire was too hot.
It's 5.82 volts.
It's got to be the hair, Papa.
Yeah, it's you just don't see it anymore.
What on the magnets that are hard to take off?
Oh, you're discovering the strength of the magnets. Nice.
I just love how I can turn this up. You see, there's 6 coils in the drive. What I did was I took all the little wires and I put them first, and then I did a direct rectifier diode into the large wire, and I did that one second. So it's really like a large bifilar coil. Be careful. And so I can turn this all the way up. And I'm not saying I'm not worried about it, but I am definitely, you know, it can go. I didn't want to start knocking everything because look at that air cap. It's very, very small. So if it starts like shaking it all, it's gonna hit something, and
Yeah,
it could hop right off of that rotor or off the shaft once it hits something. It's happened to me before.
on film.
Yeah, that's the thing, man. That's what makes it work. I mean, the coil is the heart of the pulse motor, but the switch is what makes it work.
Hey everybody, welcome to the channel. Thanks for dropping in.
Now how a transistor works. Sorry to interrupt you.
That's good.
Is you got the energy flowing through the coils, and then you got the end of that system hooked to the middle of your transistor, your collector. And then you have your emitter, which is hooked to the ground. And then you have your base, which is hooked to a trigger coil or a Hall effect sensor. And every time a magnet passes in front of one of these two things, the transistor will register that it is time to let energy flow through the circuit. So if you time it right, which is this one's timed pretty perfectly right now, when it passes in front of a magnet, it'll open, or it'll close. I like to think of it as opening because you're engaging new opportunity, but you're closing the circuit is what it really is. So I'm not trying to confuse anybody. You close the circuit when the magnet passes in front of the switch, a Hall effect sensor or a trigger coil. And it can do this at phenomenal rates of speed. So, I never knew what was really holding me back. I think it's the stability of my shaft and everything. It starts wobbling. The base is made out of wood. There's lots of things holding it back. Thanks, Peter. Yeah, that's how the Hall effect sensor works. Yeah, Hall effect sensors are awesome because they work pretty much the same as a combination between a trigger coil and a reed switch. But I still think trigger coil has got to be hands down the best way to go, because you can spin the motor, you can spin it either way. It'll go either way.
Hey everybody, welcome to the channel.
Nah.
Like and subscribe. Leave us a comment. Let us know where you're from.
All electrical motors, their specific power, RPM, gauge, wear, coils has to be wound current load to be efficient.
So you can see we got it up on here. "42 people watching."
And I would say, to be efficient, you're right. But you don't need to know the end game to get those numbers. Okay, it's like, and it's typical. For you gotta know, you gotta know your permanent strength. You gotta know. There's lots of things you gotta know. And then it's a different ride. I could never put myself in a box like that. Because, there are microns of mistake throughout everything that you see here. I've eyeballed all of it.
It's pretty good for eyeballing, dude.
I'm not saying it's bad, but what I am saying is that you don't need all that to get something to work right. And I'm not against it. I'm just saying I don't really plan. My brother knows. Yeah, I've done it before.
Yeah, and he's gotten lots of things to work correctly too.
Yeah, and it's the only way I ever learn anything. I can't trust the numbers. I never trust the numbers, especially my numbers. That's
Yeah, there was a phase there where there would be some things smoking, and that
Right.
doesn't happen very often anymore.
Yeah, so there was a lot of people there that didn't like that. That's okay. Apply a load on which one? There's already a load on that. This pulse motor is a load on that. What numbers? You can't please everybody. It's alright. I'm not really worried about it.
Right on, Peter.
Yeah, I get that. There's this one guy from K Energy, and he applies fans to his motors to apply load. Yeah, my shafts don't spin, so I'm not really worried about hooking a fan up to this stuff. Yeah, I've noticed that. I understand that.
Hey everybody, welcome to the channel. Thanks for dropping in.
That the heat kills magnetism. When the amp draw gets too high, everything loses its teeth, is what I say. It's like if it's a gear that's lost its teeth.
Ah. Fast timing.
Yeah. It only heats up like that when something blows out. Ever. With me, it only heats up like that when either the reed switch is stuck or the transistor is blown. Virtually, that means that it's constantly that it's constantly closed. That's a transistor that doesn't work. And that yeah, there's no way that can happen with this way it's built. There's got to be another way to do it. Then, if I need to put a load on this, there's got to be another way to do it.
So that's where I think the electronic piece comes in for timing.
Timing?
The frequency.
Oh yeah, pulse generator.
So that's that, and he bought the Arduino a year ago plus, and we haven't gotten into it yet.
Yeah, I got one of those tucked away. I'm definitely gonna get the processor rolling because I mean the timing isn't perfect. Well, it's really good. I mean, it's fast enough that none of this stuff is gonna overheat. I'm not worried about it.
Arduino is cheating. Maybe.
Well, I mean, if I learned Arduino, I'd probably use it. But I mean, like, learning it is not something. Learning is something I stopped doing 20 years ago. No, I'm just kidding.
Someone was gonna teach me how to set up timed pumps for my water system in my grow facility years back, and we never set it up.
42 volts in. Look at how much faster this one's going because of that. It's like it's almost doubled its speed. Oh, it's making power. It's making enough power to move this. And I'm telling you, man, it's not as easy as it looks. Well, it is. It is that easy. This coil right here is generating electricity. Nothing but electricity. It's like transformer electricity.
What's up, Only Take Money? Welcome to the channel. That's a nice. Sorry, I love that name. He asked, when does it blow up?
When I say.
That's right. So that would be an intentional thing.
Alright, so currently that one coil running the pulse motor is generating between 300 and 400 volt peak to peak spikes, an average of 160 volts, between 100 and 100 and, well no, actually it's between 80 and 120 hertz. Just this coil. And it's running a pulse motor, so I don't know what you mean by that.
Plug in the light.
Alright, we'll plug a light in too, 1000 watt. It's a 100 watt LED that's supposed to be equivalent to a 1000 watt metal halide bulb. Now I'll just say that mine don't need to push wind.
Hey everybody, welcome to the channel. Thanks for dropping in.
Alright, so we're going to put it in the loop. Now I'm probably going to need to turn the power off. And it's only going to turn on every time this thing pulses. So. probably should have set this up. Alright, this good. We're good. Alright, and then hope I got that right. Something's not right. I got another angle. This one's wrong.
No.
Right, here we go. So it takes the arc out of the switch. So there's like no load on the big one at all.
Thanks, Peter. Tell your mom to get well soon.
Oh man, sorry to hear that, Peter. Bye, man.
Peace.
Peace, my man. All right, what is each pole? Let's backtrack a little bit. An amp reader in the line. See the current strike each time. In order to classify the stator. Each pole. Okay.
Jeez.
Nice, man.
Wow.
Yeah, talk about really fast. That's awesome.
Yeah.
What kind of wire did you use for that?
Hey,
Sorry to hear that.
you love what you do, right?
I guess it's
Yeah, and then yeah, that sucks. But glad you're having a good life.
How bad is it? Was it
Okay, we'll check it out.
alright. Sweet. Yeah, man, I should definitely check that out. I am looking to do stuff with more power. I'm looking to work with high frequency. I have the voltage already that I need to work with high frequency. I just don't know how to get it to function.
Yeah, that sucks.
Yeah, that's terrible. Sorry. But we are heading into an era where that
Yeah, the
might not be a
Neuralink. We hopefully we can put some or other things that can help.
Okay.
You're right.
Yeah, man. The power, man. I'm looking for that. I mean, the most I can get out of this one over here is 1,000 RPMs because of stability. Right now, I mean, the shaft just starts going boo, and it's really a dangerous thing.
So yeah, we got to start with the foundation for sure.
That's epic.
I like how those colors look.
Heck yeah.
Drop us a like if you think that looks cool.
So there's definitely a connection over here that isn't right. But I'm not going to mess with it right now. I do know that this wave kind of opens up. It's a DC loop, so when it opens up when a magnet passes, you get the DC sine wave.
Nice.
Is it a lot of voltage? No. This thing does about 250 max on its own. That's AC voltage. It'll pull about 0.5 amps.
Hey everybody, welcome to the channel.
Hey, what's up now? Got a 32 gauge coil there with 18,000 turns in it. So, I mean, it's pretty powerful. But then again, it doesn't generate much ampage. So, I mean, how do I generate amps? How do I do that? I mean, these are 16 gauge coils over here. I should be able to generate some kind of ampage with that, right? Or is it all in the circuitry? I mean, what is it that makes amps? Yeah, I don't know. At one point, I think I had the pulse motor generating like 5 amps. And I think Chris, my brother remembered seeing it that way.
Mm.
You remember seeing those? Yeah, like between 4 and 5 amps. Sometimes it's like at 6. But I had 4 coils with cores. One of them was a 20 gauge coil. You know, I had.
Welcome back.
Welcome back. They're all down there on the 3rd shelf next to the aluminum pointer. Senor.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe, leave us a comment, let us know where you're from, if you're working with any projects at home.
So each one of these little coils has 800 turns in it. Each one of these big coils has 250 turns in it. So 800, 1050, 2100, 3050. 3,150 turns.
Nice work, dude.
Nice. Heck yeah. How tall were you when you were 2? I was climbing out of my bedroom window at 2.5.
Yeah, yeah. There goes the shaft.
And it wouldn't be shaking like that if it wasn't in the loop. So what I'm going to do is take off the loop. Look at the light now. And we got some load on the rotor too, because it's constantly on. You can hear it. Even if it was a levitating base, it would be levitating off of maybe the table. No, I haven't seen that. I don't even know how to wrap my head around how that would work. I have to look at it. Yeah, that's a really bright light now.
All right, we'll look for it. I think that means on X.
All right, sweet. Heck yeah.
Yep. We'll look for it, my man.
Heck yeah, 33.3 volts. Thanks, Crip. That's awesome.
Hey everybody, welcome to the channel. Thanks for dropping in. Drop us a like, subscribe.
Heck yeah, we're moving right along here, moving right along. I think I'm going to end up rolling, not on ecstasy, but 6 more of these, 6 coils this size with 32 gauge. Or I'm going to have to roll maybe a 26 gauge coil that's maybe a different dimension or twice as large as that. Did you ever get an education, Crip? Or have you done it like kind of like I'm doing it? And how you do it, Peter. We do it on our own with the help of our friends. We get by with a little help from our friends.
You got it.
That's right. But I mean, self-taught to a certain extent. I'm definitely not self-taught. I'm YouTube taught. I taught myself a lot, but I would just like to give credit to everybody out there.
And he does got a credential.
Nice.
Yep.
That's awesome. So, you know, when you say I gotta do it from, I gotta wipe back to front, I know what you mean.
Yeah. Yeah. Since with the base knowledge you've added to it on your own, I appreciate things like that.
Heck yeah. Since you got your education, you've learned probably more since then than you did when you got it, right? Yeah, lid motor's good. Sky collection's good. 3D PPM is good. They're all good. I've only been into lid motor and 3D PPM. I want to do Sky collection because they're all collaborating now, and I want to work with them too because you know I would like a Hall effect circuit that isn't going to blow up in my face. That's awesome, Peter. Heck yeah. I think the room to fill in the potential is extremely large here. Because here you can teach me stuff and I'll learn it. But you can't say SG and this and that because I don't know what that means. I mean I do now, I mean schoolgirl, but I mean how are you gonna know that?
Yeah, we really appreciate those ones.
Schoolgirl, that's right. And whoever came up with that is misogynist. I wonder who came up with that. Because it's like easy is what he's trying to say. It's like the back of his hand. It's so easy a schoolgirl could do it.
Boom.
I know. Yes, sir. Oh man, they got there's this one chick from China. And she's just posing in schoolgirl outfits, man, and it's crazy good. I'm not being a perv. This is totally dressed. Totally dressed. Yes. Well, okay, all right, whatever. Maybe we have a little bit, but oh my God, right? You know? There's like just multiple colors. It's all white and like kilt, but you know, green.
The
red,
kilt. I think I saw the one with the kilt.
blue, pink.
It's interesting what kind of things draw attention, but this being one of them. Welcome to the channel, everybody. Thanks for dropping in.
No, man, she's an adult. They're all adults. Wow, okay, my bad. We dove down the wrong hole. Gotta correct ourselves real quick.
Oh no, you're fine. Hey everybody, welcome to the channel.
Well, I know how you feel, Peter, man. I can feel it. The restlessness. I can feel that.
So drop a
College girl.
comment, let us know if you get, let's get back.
Yeah, absolutely. We're back. We're back and in effect. Currently, we're running a loop off of one coil over here. Alright, we're running the loop off of this coil. This is 18,000 turns, 32 gauge with a soft iron core. Alright, so we're running the loop over here to run this motor, and we also on that same coil have this light, so whenever this pulse motor pulses, this light will light up. Now I don't think the connection is as good as it can be over here, but you know, it works pretty good. It should work like that. But sometimes it'll stop like that. And it takes the arc out of the loop. There's no more arcing in the switch. It's all going into the light. Now the arcing is back, and yeah, that's another thing that I noticed. Go ahead. Alright, now I'm going to turn on the light.
Okay. Oh yeah.
Right on. What could I do to put a physical load? I think the best thing that I could do, it's not a physical load, it's an electrical load, but is to take the loop off and have the coil be directly fed into the light. Provides the most load. So like that. And then you can hear the motor will change its frequency from having the light be on constantly. And I think what we're going to try and do is we're going to try and plug something into this and see if we can turn it on. What do you mean? It's not even hooked to the power supply at all. Maybe through kinetic energy in the soft iron core, I don't know how. Or the light is my power supply? Is that it? I'm struggling. Yeah, here we go. We got a fan under here. It's a dirty fan. We're gonna see if we can make it run. Yes, it'll be quote unquote a power supply. Or it's a way into the loop. turn it on now? Yeah, that would be really neat. Okay, it's not enough power to run it.
Got that.
So what about a cap? I mean, would a cap bank work on this? Yeah, oh, I get what you're saying. It's definitely DC out of the coil. But that's because I was running a pulse motor with it. I don't need it to be DC. That's a great idea. All right. Oh, I get it now. I'm sorry. I've been up for a while. Yeah, I apologize if I sound like I'm short fused. I'm just tired. All right. So AC fan.
There, Peter just suggested something.
So you're saying I could clip
Just made
the
it
end of the drive?
a pterodactyl sound. Sorry, please go ahead.
So we'll just clip it right here and send it over to the fan. Let's give it a shot.
Heck yeah, Grip.
Alright, so we're not going to use that coil. So this is the
Hey everybody, welcome to the channel. Thanks for dropping in.
So what I've done here is effectively made the drive circuit of this pulse motor another loop. Let's see what happens.
All right.
So the light is completing the loop.
Got
That's
it.
what I'm saying. See what happens. Maybe I misunderstood.
Grip had some foresight on that one.
Alright. Oh, so I gotta flip those wires? Oh. Alright, we'll see about the AC real quick. Because I know this is AC, we just have to unplug it. anything fancy, you just check the dial out. Right. Just make sure that is.
Peter said he got his Bendini coil output to barely spin a 120 volt 5 watt AC motor slowly.
Yeah, I don't have any true Bendini coils out here.
How many times you zapped yourself? That came in from Crypt.
Four right now, and it's been with like 345 volts.
And then he mentioned a GFI circuit for a little safety. I think that might be.
Oh yeah, I got some of those in my bathroom.
Yeah.
Let's see here.
It's like, is that the name of a new company?
There's 100 AC volts coming out of this coil
Alright.
at 27 volts in. So turn that up just a little bit.
That would be where you would draw your power from.
130, 140. $150. So we got to do a direct connection with the fan. AC voltage. Yeah, see this, he's right about this being a DC light. With the AC fan, these are not going to be compatible, so I need to do a direct connection.
Hey, welcome to the channel, everybody.
Hey, what's up, everyone?
What is it hooked to?
What?
Sorry, Crip, what is what hooked to?
It's hooked up to the coil that is being measured. The one with the iron core in it. This one. And that one only. That one is not hooked up to anything else other than itself and the light and
We're still not yet.
Did you tell him which coil it's hooked up to?
I pointed at it.
Oh, I did? Alright. Yeah. Thank you. Thank you. Alright. Peter, I'm all ears. I think that if I hook this directly to the coil, then it might turn on. But I don't think it's going to work through the socket in the DC light.
Ah, I see what you're saying.
The DC socket, I don't know. Yeah, let me check the amps on it real quick. Great idea. Excuse me. Alright, so 71 hertz. The UA is 40. DC, and we're checking the AC current, right? .500 milliamps of AC current. Yeah, we're gonna try it. We're just gonna swap out this plug for that plug. Alright, it is now officially hooked up. Oh, it picked right on up, man. That's awesome.
Hey, over Unity Research Channel. You can on our channel page. There's a link to X there, and you can contact us directly there.
No luck. No luck.
Sorry, I didn't get that.
It's on.
Got it. Okay. Oh, you need a cap. Yeah, here, let me show you what he said. And it was way back here. You need a 22 NF cap.
22 NF.
Yeah, I'm not sure what that means.
Oh, I get it. We need a capacitor to make the fan work.
Yeah.
I don't have any like ceramic stuff. I got a box full of caps, but they're like 10. I got 10 volts with 2700 micro, and then I've got 25 volts with 4700 micro, and then I've got super caps with 2.7 and then 500 farad. I have a cap bank of super caps, 6 super caps in series. I've got 275 volt AC silicone capacitors.
Over Unity, yeah, you can feel free to always drop comments on the videos themselves, or definitely hit us up X for direct message. Cool.
All right, so what one out of the ones that I mentioned do you suggest I use to do that with this? The AC one? I have starter caps too. They're AC starter caps, and they are like 120 volts and 1,000 micro. So we got AC capacitors, 275 volts, right here. Yeah, that's these ones. I got these little ones that are 275. I got these starter ones. They are 1,000 UF and VAC is 110.
I think the Perfect came in with the yellow ones, but I'm not sure.
So this is perfect. Yeah, that's good. It's way more voltage than the big one.
Yeah, that grip has some foresight. But that's why we do this, so we can figure it out, and I don't know. Everybody says something different anyway, so it's all good.
So the load, it's hooked up to this coil right here, the fan. So the max amount of load we're going to have on the rotor is through this coil. Okay. Right here. This will work.
Okay, no problem. Yeah, as soon as you get back home or to a safe spot, right on our channel page where you click on the drop down, it should be there.
Yeah, I've been dying to get a hold of you too, man. I'm trying to think of other ways because, yeah, I don't know. Okay.
Papa Bale, B-A-L-E.
Yeah, and it's at M.P.H. Jr. all caps.
And the beater, here, let me show you that.
So you want me to hook it in a loop to the one end? Okay, that's not what I did, but we can do that. And if it's gonna be like a loop, let's call it a loop.
It's funny because as soon as you start, all these recommendations come in, but you're talking as you're doing it, so I want to cut you off.
Alright, so that, and then the juicy resistor on the other side.
You have a
But there's
5%
already, like-
tolerance resistor, like 100 ohms or more.
Yeah, it's right in my hand.
Boom. All right, what was your question?
I already have like 4 or 5 things hooked up to the coil already, man. I got 2 multimeters hooked up to it. Where am I supposed to hook this up?
The resistor is in series.
Okay, it's just hard to see through everything else that's out here.
No doubt.
um, no, okay, I don't know if this is right at all. You said hook it up in parallel to one side of the coil, so you hook both ends up to the same side of the coil?
From the coil, the negative side, to the power cord. Okay, hold on. From the coil to one side of the power cord. These ones? Interesting.
Is the AC capacitor to be hooked up on the negative or the positive side of the coil?
Hey Daniel, welcome to the channel. Excuse me, welcome to the channel. He asked, what are we watching? This is a pulse motor. It has magnets in it. It's a 3D printed rotor.
So you need
And
to
these
hook up the
coils provide electromagnetism
so these need to be hooked
in the
up to
spinning of the
coil.
motor. Capacitor in parallel. Yeah.
And then out the negative side, we go with the resistor. And then to monitor all this stuff, I literally got like 5 things attached to both sides of this coil. Alright, so where do I hook the fan up to? So I'm taking it, we hook it up to, because I'm putting it in a loop.
So look, what I hook the fan up to, you don't keep raising the resistance until it works.
So one of these is going to go into that. Yeah, somewhere along the line, something doesn't add up, but we're going to see. We're going to see if that works. It's going to blow up, ladies and gentlemen.
He said fan would be a load if we're generating from the power of a coil or rotor.
Yeah, we got nothing on the fan. There's way too much stuff hooked up to this coil. Alright, I'm going to unplug both the multimeters from this coil.
How many poles are in the rotor?
Mono.
Mono.
They all face north.
Hey everybody, welcome to the channel. Thanks for dropping in.
Thank you.
Leave us a like, subscribe, drop a comment, let us know where you're from.
That was a wire.
Okay.
And attracted with magnets. So I don't think hooking up this, I mean, all right.
So you're applying force but have an open spot I can coast through. Interesting. Is that... Oh, you said the coils are... The spacing's non-linear.
Yeah, that's a 9 magnet rotor. And it's 40 degrees of separation. All the coils are actually wound the same way, clockwise. Oh, wait a minute. I think they're all clockwise, or they're counterclockwise.
I'd have to see it.
I think it's counterclockwise.
Okay.
I'd have to sit down with the machine, actually.
You said they look to have different mass on them.
Oh yeah, they're very different mass. One of them 16 gauge at 250 turns, but all three of those are the same.
The ones on the sliders?
Yeah.
The ones on our slider.
So that's 250 turns of 16 gauge single file coil, the three right there. And then these are 4-filer coils with 26 gauge. And they're wound in series, so it's 800 turns pretty much. But of course, the benefit of having them be 4-filer coils, you get the repeat of the same coil imprint instead of having it be one continuous imprint. And it's maybe not a benefit, but it's a differential.
Ooh, east and west pole.
Heck yeah. I would. I would like for us all to collaborate on this stuff. From gyroscopics to pulse motors, pulse motor gyroscopics, you know, and all that stuff. We need to get our ideas out there. Just, you know, I'm very rudimentary. Like, if I'm going to do anything with circuitry, I'm going to buy a circuit and then I'm going to reverse engineer it. That's how I'm going to learn about it. Yes, Peter, yes, we all want to. I'm just trying to think of the best way we can do that, where we can all talk and conference.
Mm-hmm. So over Unity, yeah, we'll definitely. Peter's one of our moderators, and we're happy to exchange contact information.
Yeah,
And get
that'll
phone
be good. We
numbers.
can exchange numbers via email.
Okay. Oh, we are on
Oh,
the
right
last rung here.
all right, here we go. This fan is not going to run tonight. I already know this.
Thanks, Brandon. Thanks, Peter.
Thanks, Brandon. Thanks, Peter. We will gain momentum here.
Exactly.
Yeah, right, man. I mean, you've been trying to reach me for a long time now, and I've just been really trying to think of the best way that I can do that without, you know, undermining my whole project.
Broadcasting contact information.
Yeah.
Well, we might create a email
Because
later
I
on.
think the ability and I know that people do this for free, and it's what's propelling us into the next stage, sharing information. But I think that's one of the most valuable things that, you know, in this platform is capable of doing. And that information needs to have value on it.
Yeah.
Don't sell yourself short. I mean, if your information is good, you should
Well,
put a price on it.
he said he's been working for 17 years straight on this. So
That's awesome, man. I'm
Yeah.
dying to hear what you have to say. But I know, I see it both ways though, because I'm broke. I'm a broke ass.
All right.
And yeah, money makes the world go round, even now.
If you guys want to support the channel, we have some memberships available.
I'm not talking about the memberships really. I'm just talking
Just
about
joking.
money in general. You know, it's like, yeah, you can't live without it no matter how much you want to. Even if you had free energy every day of your life, you still need money. I know, Peter, you got it made, man. That's awesome, man. I wish I had I mean, I got a lot, but I mean, it's like a dedicated sponsor.
Hey, anything's
I mean,
possible,
dude,
man. I mean, you're working with a
you
lot
got
of brands. Yeah, he's not broke too. All right.
No shame, man. That's true. I totally understand. And yes, we're going to get together and we're going to talk shop and
Sorry.
whatever else we want. I think that Peter's really got it made though, man, because this sponsor's kind of like his friend.
Yes, we love the rich knowledge of the community. We love you guys.
Yeah.
We do too. Yeah, we do.
Yeah, I've viewed channel. I like what you have there. That's awesome, Peter. Jesus. Good Lord, millionaire uncle.
Yeah.
Damn, I wish I had a millionaire uncle.
Well, there are half uncles.
Right. And one of them's a really good lawyer.
Right,
So
and the other one
I'm
owns a winery in Napa.
that's awesome though, man. I mean, I talk about it like they're living next door, but I mean, I love them, and I know them. I barely ever see them, and you know, just since we're talking about family, we're going to go see that side of our family in the near future, so that's going to be fun.
But there's got to be another thing in there that's like acquaintance. My cousin's brother's sister's acquaintance's friend. There it is. You got to add another degree of separation in there.
Yeah. Twice removed from a walrus.
Yeah. That's pretty cool. I like that. Helping out vets, helping out people who need help, for sure.
All right. Well, that's totally great.
Oh, got it. Right?
Yeah, the 2024 vet.
Right.
The one that's like totally flat and has the wheels that are like 28 inches.
It looks like a Lotus, dude. Right on. I think a lot of us are there, but I don't think. Hopefully, the tide will turn. I don't know how, but it will turn.
I'm in the same boat as pretty much everybody when it comes to what they can spend their money on.
Yeah.
And I'm hoping that someday in the near future things will open up and I'll be able to give a lot more than I can right now. So yeah, man, I'm down to help people out with my knowledge, and then when things pick up, which I'm assuming that if I continue, that if we continue the way we're continuing, that I'll get at least enough traction to subscribe to other people that are up and coming.
Yeah.
And what I mean is join other people that are up and coming.
Yeah, support each other. Yep. We should take an inventory.
Yeah.
Yeah, because that's another piece, sharing parts between. I hadn't thought of that. Because that would just be like a shipping cost. And thank you for helping me, Fee. Yes.
You mean with your jewel ringer?
Got it.
You know, Ralph ring, it's weird about Ralph ring because I feel like I have a connection, there's a connection there between me and him.
Like a spiritual one?
Yes.
Nice. All right, I feel like I got about 10 more minutes.
Yeah, I'm running out of juice too, man. It's
Yeah, synchronicity.
I don't know if he likes me very much, but yeah, but as soon as I saw his face, I knew right away that I knew this guy. And that's why I keep on telling, saying to myself, I've already done all this. So it's all going to come naturally to me because I've already done it all.
It sure seems that way observing it. So that's cool to hear.
And the stuff that doesn't come to me naturally, I have to learn.
Yeah.
Okay, and there's a bridge between what you know and what you need to learn. Because as soon as you run out of what you know, you have to learn. Or, that's where it stops, what you know, and that's not everything. Thumbs up.
Rock and roll.
Be careful driving unless you have a self-driving Tesla,
Right.
and then it doesn't really matter.
He was like, my wife is texting me while I'm driving as he's having a conversation with us.
That's awesome. That takes a lot of skill.
Yeah.
I hope that you're not in a really busy area.
No doubt. Yeah, bro, that's impressive. How you just kind of forced that out. That was a brute force thing.
It's kind of big, so I hope it came out the right orifice.
We're talking about this one right here.
Yeah. So I think that the 31 gauge and 32 gauge coils is going to be what we're going to end up using. Because the 26, maybe a 30 gauge, we could use 30, but I think that the 26 gauge gets way too hot when it doesn't hit. It's got to hit every time, and this thing just doesn't do that. Yeah. The baby gyro, oh man. It's like I knew exactly how it was gonna, I knew what was gonna happen when I put it together, so. And no, I didn't do any homework, except for look at a picture. But I put it together, and I knew that the forces that were opposing would, I don't know if it actually made it go faster in this one, but they did go the opposite directions on their own.
Yeah. Untethered.
And because of the commutator brush, there was a lot more friction with the gyroscopic part of it. The rotor spun really good, and gyroscope spun, but not as good because of the contact. Oh, that's awesome. Well, thank you very much, ladies and gentlemen. I will put my email address in the description. And anybody that would like to get a hold of me, please email me. Thank you very much. Peace out. Have a great night.
Oh yeah, it's well on its way.
Yeah, it's got to be a spark gap thing though. There's got to be enough, like either voltage or current going through it to make it jump. Unless we're going to do wireless electricity, in which case I got a lot to learn. All right, bye now, everybody.
Have a good night. Thank you for stopping by.
Peace out.
Like, subscribe, thinking about join up, and we'll see you next time.
Peace.